This is a quick note I wanted to add about odd functions and how you can actually look at their graphs, maybe from a different perspective. So I've drawn part of an odd function just for the positive values of x. Okay, and we know from the previous video an odd function is such that f of minus x is going to be the opposite of f of x. So for example, here I've got a piecewise linear function. Okay, so it's pieces of lines glued together that form a curve, and you can see I have indicated 3 points. There's actually another one here. This is an empty dot here, so it's not defined right now at 0. So this is 0, 1. Okay, so I've got 4 points. Now I can look at what, for example, would be f of minus 1. So f of minus 1, according to this equality, would be the opposite of f of 1. Now f of 1 is 1 on the graph, so it would be minus 1. So this is what you're kind of shown in the previous video. So f of minus 1 is minus 1. It would be right there. Okay. So one way to look at it is f of 1 would be at the same height as f of 1 is basically the height of this point here that I've circled. Okay, so it's 1. If the function was even, okay, we'd have f of minus 1 equals f of 1. So at minus 1 we'd be up there, but putting a negative sign there, we have to send this dot on the other side. So in other words, we're kind of going reflect about the y-axis and go down. So this is one way of looking at it. So I can do this with all points. I could reflect about the x-axis. If that was the only thing that would happen, I would be dealing with an even function. So I'd have to go a little bit further, maybe like here. Okay, so this is minus 5/2, right? And but then if it's odd, you have to reflect also across the x-axis. There's like 2 reflections going on. So we'd end up with the point 5/2, 3/2 being sent on this point here, which would be, well, actually maybe it's a bit closer to here. So it would be minus 5/2, minus 3/2, like this. Okay, and I could do the same with the other point here. You send it across, and then you flip it across the other line, and you get sent here. So you get this. You're going to get that at minus 4. It's minus 3. So that's one way to look at it. Okay, and our curve would look somehow like this. Also, here, this point here, this point here, even though it's undefined there, like there are points really close to it that are defined, so we're still gonna look at where that part of the curve is going to be sent. It's not too hard to see that if you take any point here on this part of the line and you reflect them across the y-axis and across the x-axis, you're going to end up with this line here and an empty dot here. So that would be what the entire odd function would look like if it'd be defined. Well, I mean, and then you could just keep on going like this, maybe, if it'd be defined on all real numbers. But what I want to show you also is that there's another way of looking at how the points are obtained. So instead of having like a reflection across the y, across the x, you could actually look at it from the point of view of reflecting across the origin. And what do I mean by this? Let me pick another color just to illustrate. So take this point, for example. Okay, so a reflection across the origin is basically you link the point that you want to so this one we want to figure out how what is going to be its equivalent on the other side of the x-axis. So so here I'm again dealing with what would be f of -1. So at -1, what would be the f coordinate? Well, what you do is you draw a line like this and you extend it so that these two have the same length, and then you're going to end up with the point you're looking for. Okay? So let me actually redo this with from this perspective. Okay, so 1, 1 gets sent onto -1, -1 by essentially reflecting the point 1, 1 across the origin. Okay, and I'm going to do the same with the other points. For example, this one, you draw a line like this, and then you, if you extend it, you're going to end up at -5 half, 3 half. So you're going to end up here. Okay, and let's do the same with this other point, like this. So we extend it a little bit, and we're going to end up here at -4, -3. Okay, and if we do this with error, for example, points on this line, you see we actually end up creating this part of the curve. So we're going to end up again with something that looks like that. So it's really a reflection across the origin. So maybe let me go through another example. So let's say I want to figure out, like, is this the graph of an odd function? Okay, well, visually we can try to check it using reflections across the origin. So for example, take this point, okay, and then try to reflect it across the origin. You can pretty much see we'd end up over here normally. So, and actually at this x value, we're down here on the curve. So we should be here, but we're elsewhere. So this is not an odd function. Like visually, we can see it. Like in pretty much all points, would not satisfy the fact that on the other side, it's you get a point on the curve that's obtained by reflecting the point on the right hand side across the origin. So for example, I can do it with a third one. You can see it that, or maybe here it actually kind of works almost. Okay, but we see that if we have an odd function, at least the left hand part of the curve would have to look like this. Okay, if the right hand side is what we know is true, if it be odd on the left hand side, we know exactly what the curve would look like. It would be the part in blue and not the part in red. So this is not an odd function. So we could actually write this down. No, since if it would be the left hand side would have to be the curve in blue. Okay, so this is a good way of visually of checking, like, is this an even or is this an odd function? For even functions, you just see if so for example, like maybe do this quickly, but if it be an even function, the other side would have to be a reflection of the right hand side across the y-axis. So visually you can easily tell if a function is even or odd.